Okay. Okay. So good evening, everybody. So we are going to go on to introduction to Python, but now we're going to focus on machine learning. It turns out that Python is used a lot in the community of people that do machine learning. So it was good that we learned a few things about Python last week. So then many things we will do now, we'll be able to do in machine learning, but using Python. Okay. Of course, you can do machine learning if you like in C, C++, and different things, but most of the community, they do their machine learning with Python. Okay. So I sent you a booklet, so let me try to show it. Okay, view. No, I won't do a view because if I do a view, you won't see everything at once. I mean, you will see everything at once and it won't be good. So let's fit the width. Okay. And then I can share my screen with you. Okay. I think everybody can see my screen, right?
Yes.
Okay. So it's machine learning with Python, a tutorial booklet. I'll tell you how I generated this, how I got this. It was generated by AI. I gave the topics I wanted. Okay. And then I told it's Gemini 2.0 Pro. Okay. It's experimental, but they allow you to use it for free up to a point. Okay. So then I gave it some prompt, told it the topics I wanted, told it I wanted a tutorial booklet with exercises, and also told it to write it for me in LaTeX. So we created the LaTeX code, compiled the LaTeX code, and this came out. Of course, they tell you that you have to check that it's correct. So I looked quickly to see that everything was correct and everything. It took me time to know, okay, which AI code would be able to do this, okay? And so I tried ChatGPT, regular. It gave some skeleton. I tried DeepSeek. It gave a skeleton. But I found out that even if you try Gemini, just the regular one, it will just give a skeleton also. But if you try Gemini 2.0 Pro, okay, they allow you to try it. It's experimental, but it produces something very good. Okay. And then I quickly looked through it to see that it has the things I want. It makes sense. It has probably more than what we need. So this is good for reference. I sent you another booklet, which is a short thing that contains quite a number of commands that you will use when you do machine learning with Python. Okay. So I think, okay, so I said all that to say that, so generative AI is based on machine learning. So they're able to use machine learning to be able to make predictions and be able to write this text and do many things, okay? So ChatGPT, DeepSeek, Gemini, Copilot, they are based on machine learning, okay? And they're able to do a lot of things for us these days, okay? So welcome to learning about it. If this is your first time, if this is not your first time, okay, then welcome to refreshing about it. Okay. So the main thing about machine learning is that, okay, they give all the story, but don't worry about all the story. The story is that you can get the computer to do something without actually programming it to do it. Okay? But the main thing we use machine learning for is just to make predictions. Okay. Machine learning, if you do it well, can help you to make predictions, even in cases where you did not think of before. Okay. And then it can help you to see things in the data that you didn't see before. So this is possible. So this is it, data insights. It uncovers pattern and insight in large data sets that humans might miss. Especially if the data is a lot, then you may not know that this particular thing that you're interested in depends on another variable or this other variable. Okay, but with machine learning, they can help to discover those patterns. Okay. People use it for complex problems like spam detection. Mails that come to you, you can use machine learning to detect whether they're spam or not. There's some things that are simple to do. For instance, you can decide that if it has certain words, then it is spam. And if it doesn't have those words, it's likely not to be spam. Okay. And then you can also, but sometimes you have to train the machine. So sometimes when it is not spam, it classifies it as spam. So, you can go to Google and say, this message is not spam. Then it's trying to learn and improve its model to know that it's not spam. Okay. As we go along, some of these things will be clearer to all of us. Okay. Today, we'll really just talk about data and maybe a little bit about how to clean our data. And this is the main thing we'll talk about today. And then when we meet on Wednesday, we'll talk about how to really do machine learning. And then when we meet on Friday, I hope we'll be starting on some projects. Okay, so there are three main types of machine learning. One is supervised learning. Okay. In supervised learning, what happens is, sorry, if you hold on, I want to be able to write and show you what I'm writing. So let me try to quickly do that. So that I'll be able to write. Actually, I could do this so that I just write. Let's see. I want to be able to write and show you what I'm writing. So give me a minute to be able to do that. So I want to write and show you what I'm writing at the same time. I'm supposed to go. Let me pause the and then I'll share my screen. Okay, I think everybody can see my screen. Okay. So there are three main types of machine learning. One is supervised learning. So one is supervised learning. I'll tell you what happens in supervised learning. Okay. In supervised learning, what you actually have is you have a target, which is output, and you have input. Okay. Let me add a page. Okay. So you have a target, let's call it Y. Okay. And you have inputs. So I'll call it X1, X2, X3. Okay. And so let's say you have the price of cars. Okay. So you have a different cars. Okay. So car 0, car 1, car 2, car 3, car 4. Okay. And then here we have the price. So the price, for instance, could be this. So let's have the price as 8 million. Another one is 12 million. Say another one is also 12 million. Another one is 4 million, let's say 20 million. Okay. So these are the prices of cars that we have. Okay. Our target now is to predict the prices of the car, knowing some variables. So one of the variable here could be the age of the car. Okay. Another variable here could be the color of the car. Okay. Because if you have a car that is green, I think it would be cheaper than a car that is black or white. Okay. Another variable is let me think of another variable that people use for, yeah, the number of kilometers. Okay. So you have all this. Okay. So what we want to do is so this Y is called the target. Okay, or yeah. What we want to do is, if you give me the age, color, and number of kilometers that your car have run, I want to be able to predict the price. So in this case, this is the price. Okay. So is it possible to do it? If you know the age, the color, and the number of kilometers your car has run, you want to be able to predict the price. Okay. So these are some of the things. So let's say this is 2 years, this is 1 year, this is 3 years, this is 1 year, this is 1 year. Okay. And then the color, you can have red, this is green, this is black, and other things, blue, white. Okay. And the number of kilometers, let's put it in thousands of kilometers. This is 50,000 kilometers. This is 20,000 kilometers. This is 100,000 kilometers. This also is 100,000 kilometers. And maybe this one is 200,000 kilometers. Okay. So you have something like this. So your target goal now is giving, so this Y, we call it Y. Okay. It depends on X1, X2, X3. So it's like saying that the price of the car, okay, it depends on the age of the car. Okay, that's X1. Depends on the color of the car. Okay. Depends on the number of kilometers. Okay, so we want it that if you give me the age of the car, the color, and the number of kilometers, I should be able to tell you with reasonable accuracy what the price of the car should be. Okay, so this list I've given you is too small, but you do it for many cars and you have a list, even going up to thousands of cars, hundreds of cars, thousands of cars. In some cases, you can do millions of cars if you go across countries. But let's say you stay within a country, you can go up to like thousands of cars. And then the goal is to say, once I give you the price, age, once I give you the age, color, number of kilometers of another car, what's the price? So if I give you that the age of the car is 3 years, okay, and it's a red car, and it has done 40,000 kilometers, 40K kilometers. Okay. So if you do this, so what's the price of the car? Of this car? Okay. So this is basically the way we will do this is by using supervised learning. Okay. Okay. The reason we call it supervised learning is because you already have a label for all, you already labeled all the cars. You have a price for each of the cars, okay? And you have the age of all the cars, okay? You have the age, the color, the number of kilometers of the car, you have all this information, okay? And then given all this information on the right, you want to predict what is on the left. So in this case, they say that the data has been labeled, okay? So that means you have the Y values and you have all the X values, okay? Okay. At this point, it may not make sense. You say, okay, yeah, so what else can you have? Okay. So this is essentially supervised machine learning. Okay. It's supervised because you already have all the data that is labeled. Okay. Now, another thing you can do is, for instance, you want to know the price. Sorry, I'm thinking about prices of the house. Okay. As a function of the square area of the house. Okay, the number of bedrooms. Okay. Maybe the number of bathrooms or toilets that are there. The neighborhood. Neighborhood. Okay. So other things that you want to know. Okay. You can try to find different other factors that will determine the price of the house. So then you want to know what the price of this house should be if I give you all these factors. Okay. So you can use machine learning for that. In this case also is labeled. Okay. So now, apart from supervised machine learning, okay, you can also do unsupervised machine learning. Okay. In unsupervised machine learning, basically you only have the labels. So all these properties on the right, you have them. And then the system has to group them, has to put them in groups. And then, but when it puts them in groups, it cannot tell you, say the price of this, the price of that, but it just helps you to know which ones are in this group, which ones are in that group. Okay. So for instance, if I give it all this, let's say I don't give it Y, I only have the age, the color, and the number of kilometers. You should be able to tell me that car 0, say car 0, 1, and the same group. Maybe car 2 is in another group, car 3 and 4 is in the third group. Okay. So you should be able to group the cars based on some property. Okay. So this is what people do when they do unsupervised machine learning. They want to be able to group it based on some properties. And the properties are not known to anybody. They are known to the machine, to the model. And it will just somehow figure out that if I put these ones in this group, then I should get, if I do group them this way, cluster them this way, then this should work. I'm going to give you an example just now. Okay. An example I want to give you with supervised machine learning. Okay, has to do with, let me think. Okay, let me first draw the diagram. So if I have some points here, okay, this some variable, let's call it x1, and I have other points here, okay, and I have other points here, okay, and I have other points here like this, okay. So this is some property, let's call this one x2 and this one x1, okay. So the way I have done it, it seems as if I can put them into groups. So I can put this into one group, put this one into one group. So what does it mean? It means all the ones in this group have x1 in a particular range, okay, and have x2 in another particular range, okay. What about the ones in this group? They have x1 in a particular range and x2 in a particular range, okay. So I'm able to group it this way. What about these ones? It's not so clear, but then I can try to draw a line like this and say that these ones have x1 and x2 in some range, x1 and x2 in some range, but it's not clear that it's x1 and x2, okay? But the machine is able to figure it out that if you, in this case, it will be some linear combination of x1 and x2, okay? That it will use to decide that the ones on the left here are in one group, the ones on the right here are in another group. Okay, so in this case, which is unsupervised machine learning, you can let the machine itself group the items. So it will use some criteria. It has all the data. Say, for instance, it has all the age, the price, the number of kilometers of the cars, and then it will use that data to group the cars into different groups. Okay, these groups may correlate with the price. They may not correlate with the price. They may correlate with where the cars are made. They may not correlate with where the cars are made, but they just put them into groups. Okay. So machine learning is able to help you to group them this way. This grouping can be important in different scenarios. So this is unsupervised machine learning. And then the last one is reinforcement learning. Okay. So let's say there are two restaurants that you want the computer to help you to pick which one to go to eat. Okay. Let's call this restaurant 1, restaurant 2. Okay. You know, one thing you can do is you can visit yourself, do the analysis, and say restaurant 1 is better than restaurant 2. So we go to restaurant 1 each time. But you don't have to do all that. The computer can look through the data and choose which one is better than the other one. Okay. But not only that, you don't have to program the computer to do that. You can let the computer test itself. Okay, so this ones here, they call it the environment. Okay, and then the computer here, you can call it the agent. Okay, so you can tell it when it starts. It will go to restaurant 1 with probability 0.5, and it will go to restaurant 2 with probability 0.5. Okay, it will taste the food here, maybe, and then if the food here is very good, okay, it will give the agent a reward if the food is good, okay, and then the reward it gives it will increase the probability of the agent visiting the place next time. Okay, so the first time it goes to this restaurant, it gets a reward, okay, positive reward. Okay, then the probability of going here will increase. Let's say it goes to 0.55, and the probability of going to this one will decrease. So let's say it will go to 0.45. Okay. Okay. Now it's only visited one restaurant. Then the next time at random, using these probabilities, it will visit one of the restaurants. So let's say it visits restaurant 2 with probability 0.45. Okay, it goes there and then it samples the food and it will return a reward to it to say maybe it's a negative reward. Okay, so the restaurant 2 was not good. So because it's negative reward, it will reduce the probability of going there next time. So maybe it goes to 0.42. Okay, and it will automatically increase the probability of going to the other one. So now the probability of the other one becomes 0.58. Okay, so now using these probabilities again, it will visit at random one of them. Okay, of course the probability of visiting restaurant 1 is higher, but it can still visit restaurant 2. So you don't shut off the visit to restaurant 2. So it keeps doing this off and on, and the reward, if it's positive, keeps increasing the probability of going to restaurant 1. At the end, what will happen is that the agent will learn that it gets more reward by going to restaurant 1 than going to restaurant 2. So it's not that it will never visit restaurant 2. Okay, there's still a small probability of visiting restaurant 2. Okay, but it has learned that it gets more reward from visiting restaurant 1 than restaurant 2. Okay, so you can, so in this case, you see, I didn't tell the computer or the agent that restaurant 1 is better, but it goes there itself and then it checks, it gets a reward. Okay, and then the reward encourages it to keep going to restaurant 1. It's not like you program it already to say, okay, restaurant 1 has so and so thing, go there every time or go there. Okay, and restaurant 2 does not. No. Okay, so this is something you can use machine learning to do also, to train so that it goes in a particular path rather than another path. Okay, for instance, you can try to see different things. For instance, you can look at I am, okay, and I have, and you can count the occurrence of I am or I have, but not for everybody. So you can do it for a particular person. So in this case, I am, you can think of this as restaurant 1, and have, you can think of this as restaurant 2. Okay. So after I, what follows? Okay. So for a particular user, it could be each time he's typing or he's typing a letter, he's always saying, I am this, I am this, I am this. Okay. So then the computer is getting a feedback, or the model is getting a feedback that I am is, but he gets more rewarded than I have. So the next time the guy types I, very likely the word am will show up as a suggestion for him to use. Okay, because the machine learns that typically when he does I, am follows it. Okay, or maybe if he says yeah, because some of you also, when you go on your Google and you type dear someone, or you try to type dear, okay, let me give an example. There's somebody I typically will write to. He was my boss, okay, but I won't say dear boss. I'll say dear Uncle Mike, okay. So later on, the computer learned that once his name appears in the email and I try to respond to him, the email does not say Uncle Mike, okay? The name does not say Uncle Mike, but the computer learned that Each time he sees this name, then the next thing that follows is Uncle Mike. So then he tries to write it for me even before I think about it. Okay. So this could be an example of reinforcement learning. Okay. So when you do machine learning, the sweetest part, if I may say for me, is developing the model training, maybe model evaluation also. Hyperparameter tuning sometimes is very important, sometimes is not too important, okay? Because sometimes the parameters they have already is good enough. You can improve a little bit if you do hyperparameter training. But model training and model evaluation is sweet, okay? You do the training, you do the evaluation, is very good, okay? Usually problem definition is I already do it because before I start with the machine learning, my goal is clear already. The part that is more difficult is data collection, because you have to get the data that you need. And this takes a lot of effort, energy, time to collect the data, okay? Then the other one that takes a lot of time, energy, and everything is data preprocessing and exploration. People typically call it cleaning the data, okay? So cleaning the data takes a lot of time, effort, energy to do. Data collection, of course, takes just a lot of time and energy. Okay. If you have clean data, then okay, model selection. When I worked in a research group with Dr. Kristen and some other one, we found out that there's a software that can help you to do the model selection. It will try many models for you automatically. Okay, you just give it the data. It will try many models. Later on, we are going to see the different kind of models. There's linear regression, there's random forest, there's say XGBoost. Okay, so it just tries many models and tells you, and then gives you the accuracy of each model, and then you decide which one to do. So model selection became like almost like automated thing to do, okay? But the data collection and data pre-processing takes a long time. Okay, imagine in this case that I said about the price of an age, color, kilometer of the car, and you have tons of cars, okay? Suppose there's one car, you can't tell the color. Is it brown or is it red? Okay, so what should you put here? Okay, if you have a missing information like this is not something good that you can use in machine learning, okay? Or there's a particular car that people did and we don't know how many kilometers is there, because the technician that was collecting the data, he forgot to check. Or he checked, but the odometer was scratched, so he couldn't read, he didn't know exactly what it was, you know? Or someone decides how old is the car. He looks at it, the VIN says it's this years old, another thing says it is that years old. So he doesn't know what's the age of the car. So there's missing data in this thing, okay? So if there's missing data, how do we deal with it? Okay, so if there's missing data and things like that, then your data is not clean. You need to clean the data. And this takes quite some time, effort, thinking to know the best thing to do. Because sometimes you can say that, oh, the missing data, there are not many percentage-wise, so I can drop all of them. So all the lines that have missing data, I can just drop them. So this is one possibility. You can just say, the lines that have missing data, there are not many. Let me just drop all of them, okay? So if you have like 200,000 and maybe 3,000 have missing data, yeah, you can say I can drop it and I can still do my machine learning. Or another situation could be that, oh, the data is missing. Let me use the average of everybody and just put it there. Okay. So you can do that also. People do different things. Okay. But you have to clean the data somewhere, one way or another. Okay, that takes some effort. So then you train the data, train the model, and then you evaluate do the evaluation, and you have to do the evaluation in such a way that is objective. We'll look at how to do all this later on. And then here we just explain why many people use Python for machine learning. Okay. The last time we met, not the last time, last week when we met, we spoke about NumPy. We spoke a little bit about how to open files and to use files. But today, when we get to the part, we'll talk about pandas. It's a library that's very, very good for manipulating data. Okay. And one of the good things, the scikit-matplotlib is something that helps to visualize the data. Okay. It creates very good graphs. Okay. And then there's scikit-learn, which actually which has libraries that actually do the training, modeling. Okay. There's TensorFlow, PyTorch, Keras that people can use for neural networks or deep learning. I have to tell you, I'm not an expert in this, TensorFlow, PyTorch, Keras, and so I don't do much of this. One of the reasons is I deal with scientific data, and with scientific data that I deal with, we don't have lots of data. So if you don't have lots of data, the neural network or deep learning is not very useful, because for neural network deep learning, you need to have tons of data, like millions and millions of data points, which the scientific work I do really is not there yet. Okay, so I'm not like an expert in TensorFlow, Python, Keras. The interesting thing with using Python for machine learning is there are many people that are doing the same, and the community is large. So one thing I found when I was younger, if I need to do something, I'll write the code and try to write the code myself. These days, I just feel somebody has done it already and has written the code, and I can just adapt what they have written. I'll go online and look for a library. And for the most part, many times the library is there, or a library that I can easily adjust my code in a little way and just use that library. So for the most part, I really don't have to do a lot of coding, but know how to get the libraries and how to interface with the libraries. Okay. Yeah, so this is one of the things you realize with Python, that many people have done many things, and so you can just stand on their shoulders. Okay. So we already did something with NumPy the last time we met. So I'm going to just repeat a little part of this. So like before, if you've used Anaconda before, you don't have to, let me see. If you've used Anaconda before, you don't have to start. Okay, so I want to open a page with Anaconda. So I go here, start. There's Anaconda. Okay, I can click on it. Because I've used Jupyter Notebook before, I don't have to go to Anaconda Navigator. If this is your first time to use it, once you install it, you go to Anaconda Navigator. It's going to bring out some green thing, and then you choose Jupyter Notebook. Not Jupyter Lab, but Jupyter Notebook. You choose it, and then it's going to bring up what you need. I mean, okay, I can do it again. So you go there. I'll wait for it. It's going to come up. At the same time, you can go to okay. You can use Google Colab. So if you go to research, colab.research.google.com. So colab.research.google.com. Okay. So it will take you to a page. So in this case, you have to be online. So it's going to take me to that page. So while my actually it's still loading for me. Sorry, I'm doing many things at once, but I think it will work. This green thing is coming from the Anaconda Navigator, not from Google Colab. Okay, so if you've not signed in before to Google Colab, there'll be something on this right that says sign in. So once you have a Google account, you can use it, okay? Once you open your browser and you've logged into your Google account, so I've logged into my Google account, that's why I have this, okay? So my account is there, okay? So if you just do collab.research.google, okay, this page comes up, and even if you don't see this, you can go to file and you can open new notebook in Drive. Okay. So I can open a new notebook in Drive, and it's going to open a new notebook for me in Drive. And I can type all these commands that we have here. This green thing that you see is still my Anaconda that's trying. Whether scikit-learn has been installed. But Pi is already there, you don't have to install it. Okay. Pandas is already there, you don't have to install it. I have to check whether matplotlib. I think matplotlib also is there, you don't have to install it. Then I don't know whether scikit-learn is there. Let me see. I don't know if this is what I'm supposed to do. Actually, you never import scikit-learn this way. You import a particular library from scikit-learn. So, okay, there's no module called scikit-learn. So you import a particular library from scikit-learn. This is what you do. So you don't do this. You do something like from scikit-learn, import something. So let me give an example. Okay, and then we'll start on. Yeah, I'll give an example and then we'll start on NumPy. Okay. Okay. So yeah, so I won't do this. So you have to do something like, say, from sklearn dot pre-processing import standard scalar. Okay. So it's going to import it. So you see it already did it. That's why I have 0 second. Okay. And this is the second thing because there's already scikit-learn and it has a standard scalar already there. Okay. And you can, if you want, you can do a regression. And then also the thing to do the regression is already there. And you can just import it. There's a website for scikit-learn, and the website tells you the different things the different libraries that you can import and use for scikit-learn. I want to, without going online, I want to be able to tell you what you can do for, say, regression or any of this thing. You can split, you'll split your data and everything. So let me give an example of what you do. Okay, so if you do something like from sklearn dot linear model, import linear regression. Okay, so you can import this and then you can use, you see, it already did. So it already has scikit-learn. So it already has, what does it have? It has NumPy. Okay. It has pandas. It has scikit-learn. Matplotlib it has already. Okay. So these are the ones you can use in. Yeah, so these are the ones you can use in Google Colab, and they're already installed. You don't have to install them. If they're not installed, you can install them by doing pip install. Okay, NumPy. Okay, if I do, and then shift insert. It is, you see, in this case, it tells me the requirement is already fulfilled. It's already satisfied, so there's no need to install anything. Okay, so this is already there. If you are working on your own laptop, for instance, and it's not there, okay. The good thing about Anaconda is many of these things are there already also. So this is the Anaconda thing that finally came up. So you look for Jupyter Notebook. So there's Jupyter Lab. This is not what you want, but there's Jupyter Notebook. You click it, you launch it. It's going to launch something in my browser. Finally, last week, we looked at Pydroid. If you have a cell phone, a smartphone, you can use Pydroid on the smartphone. Unfortunately, for the smartphone, you have to install the packages yourself. So I know, for instance, matplotlib is not there, so you have to do pip install matplotlib, and then you open a terminal and then do pip install matplotlib, and then it will install the matplotlib for you. Okay. Or if you need NumPy, I'm not sure NumPy is installed by standard. So you have to do pip install NumPy and then it will install it for you. Okay. So so I'm going to use Google Colab now. So let me give this a name. So this will be April 28th. Okay. Okay. So I'm going to, okay. So I'm going to take some of the examples here. Okay. I'll illustrate it, and then this is just a Python list, this one. Okay. The problem with a Python list, well, there's no problem with it, is that if you have a list 1, okay, and you have another list 2, okay, and you try to add them together, it will not add them vectorially like you want vectors to be added. Okay. So we saw that before. It will just concatenate them. Okay, but this is not what we want many times. Many times we want a vector 1 and a vector 2 to be added. Okay. So this, like we have written it, it looks like a vector. But if you do 1, 2, 3, 4 plus another 1, 2, 3, 4, okay, it's not going to give you. Okay, let's go then. Okay, so if I say V1 is 1, 2, 3, 4. Okay, and I say V2 is 3, 4, 5, 6. Okay. Now, when I add them together, I want to get 3 plus 1 is 4, 2 plus 4 is 6, 3 plus 5 is 8, 4 plus 6 is 10. Okay. But if you do this, it's not going to give you that. You see, just put the two lists together: 1, 2, 3, 4, and then 3, 4, 5, 6. You just put the two lists together. Okay. But this is not what we want. We want it. Okay, this is sometimes not what we want. Actually, when you do machine learning, this is many times not what you want. You want it to write it as vectors. So one thing you can do is you can write this as a vector array. So in this case, I would say this is, sorry, first I need to import NumPy. Actually, I should have done it without importing. Then you'll tell me what was wrong with it. Okay, so I will import NumPy as NP. This is what people usually do as NP. And then V1 is a NumPy array. Okay, so this is how you do it. And V2 is also a NumPy array. So it's no more if a list. Okay. And if you print V1 plus V2, it gives you exactly what you want. 3 plus 1 is 4. 4 plus 2 is 6. 3 plus 5 is 8. 6 plus 4 is 10. So it does exactly what you want. But it's because I promoted them to NumPy arrays. They call them n-dimensional arrays. Okay. So if you want to create an array that is 2 by 3, okay, there are different ways you can do it. Let's say array V3. I want to create a matrix. So it's something like 2 by 2 array, or let's say 2 by 3. So it's going to have 2 rows and 3 columns. So can do the first one like this. Okay. If you like, this one I hit enter. The reason I do it is so that I don't confuse myself. So now I want an array with 2 rows and 3 columns. So let's do 4, 9, 11. This is the first row. Okay. The second row, I can do it here also. 6, 12, 1. Okay. So this one I've written is the first. So first I put everything in this. Sorry, let me do. So V3, I put everything in this quote, in this braces. Then the first row, I want to be here. And then the second row, I want to be here. Okay. If you like, I hit enter because I want to put a space and I want to align them like this. Okay. But you don't have to align them. So you can do this. And if you like, you align them like I'm aligning them. If you like, you just put it this way. So let me comment the first one out. Okay. So I do this. And if you like, you can print V3. Okay. So it wrote it exactly like I've written it. I can decide to write V4. So like I told you, like this. And then this one is in braces. I put a comma. And then the next one, I actually want it to be, I have to check whether, okay, like this. So in this case, I put 3, 1, 1, and then 4, 6, 2. Okay. So now I put it this way because now it looks like a matrix with 2 rows and 3 columns. Okay. If you look at this one, once you get used to it, you will see it that it has 2 rows and 3 columns. Okay, but now I put it this way. Let's do shift enter. Okay. So I have this, and if you print it, unfortunately, if you just print it in a row, everything like this again. This is just for visual effects so that I can see that there's this row and this row. Okay. Then you can look at the shape of the array, and you can do different things to look at the attributes of the array. You can look at the shape of the array. You can look at the number of dimensions. You can look at the size. You can look at the data type that are in there. Okay. So for instance, if I tell you to print v4.shape. Okay. The output will be 2, 3. 2 means there are 2 rows, 3 means there are 3 columns. Or if you think about it, it means there are 2 objects in it, and each of the objects has 3 items. Okay. So if you do this, so right. Oh, sorry, I made a mistake. Yeah. So I need to make it a numpy array. So I put everything as a numpy array. Okay, so now it's a numpy array. Before it's just a list. I put shift enter. So when I print v4, it prints this way. So this is a numpy array. And I can print v4.shape, and it tells me there are 2 rows, that's the 2, and there are 3 columns. But there are 2 rows, and each of those rows has 3 items. Okay, this is what it's telling me. So for V3 also, you have to make it into a numpy array. So actually, I can do V3 is this, and I can do V3 again, is np dot array. Okay, V3. So you can do this. So first it creates V3 as a list, and then it's going to take the list and make it a numpy array. And I can print this. Okay, and I can print V3, and it's a numpy array now. And you can ask it different things. So for instance, I can ask it the dimension. It's a 2-dimensional array. So I can say print np dot number of dimension. Okay. If you wonder where is all this, so it's exactly in this thing. So you can see here, there's array dot number of dimension. You can get it. You can get the size, array dot size. You can get the type. Okay. Array dot size tells you how many elements are in it. Okay. You can get the type. Okay. And it will tell you what the type is. Okay. Another thing that's useful to do is, well, as you see, so I can do print np, sorry, v4.ending. Okay, I can print v4.size, and I can print v4.dtype. Okay. I can print all of them in one line, and it's 2 is the dimension. It's 2-dimensional array. The size is 6, and then the type is actually 64-bit integer. Okay, so these are some of the things you can do. Another thing you can do is you can, okay, when you have an array, you can get elements of the array. Okay, okay. And you can do different things with the elements of the array that you want. So one of the things I want to do is, let's go back to this, and you can see another way to get an array. So here you can get a 1-dimensional array that goes from 0 all to, but not including 10, all the way to 9. So you do that with this np.arange, okay, 10, and it will give you the element. The first element is element 0. The next one is element 1, element 2. Okay. Unlike that. Okay. And then you can get, like, if you want to get the last element, you just do element -1. Okay. So I'm going to do this. So let's do exactly what's in the book. Okay. 10. So it's going to do this, and if you print, okay, it gives you exactly 0 to 10. If I want to get the last element, I will just print what should I do? Okay, so -1 will give you the last element. If I want to print elements 4 up to, but not include element 6, so you can do that also. So you start with 4 up to, but not including element 6. Okay, so our -1 is the last one, and this is 9. Okay, and this is what it printed here. Then I say 4 up to, but not including 6. So to start from, so this is element 0, element 1, 2, 3, 4. Okay, 5, because it's up to, but not including 6. So to go all the way to this. What if I want to print 4 to the last one? Or I want to print 4, but not the last one. Okay, up to, but not including the last one. So I can do print from array 4, 4 up to, but not including the last one. Yeah, so you printed 4, 5, 6, 7, 8. Okay. Someone will ask, what if I want to print the last ones? Okay. So what do you think we should do? I want to print 4 up to the end. What can I do? Okay. So if you just do this, it will print from 4 up to the end. Okay. Because if you don't put anything there, it's going to print everything up to the end. Also, if you don't put anything at the beginning, it's going to print from the beginning all the way. So this will print from the beginning up to, but not including the 5th one. So if I do, okay, this will print up to, but not including, sorry, what am I doing? I made a mistake. Okay. This will print up to, but not including the 5th one. So it printed 0, 1, 2, 3, up to, but not including 5, so 4. So you can do this to do the slicing. Okay. And then you can add the elements together. You can subtract them, the vectors together, and you can subtract them and do different things. Give me a minute. I need to. Okay. Okay. Let's take a little, like a 3 minutes break. The reason is I need time. laptop. Let's see. Okay. So so there are many other things you can do with the NumPy. So if I create an array that is just like this thing say, okay, let's call it M1, which is so this we create random numbers. Um 3 by 4. 3 rows, 4 columns. And then I can print it. I can print it. So these numbers are random numbers from the standard normal distribution. And I can take the mean of all these numbers. So it's np dot mean. And then I'll put the array there. I'm going to take the mean, and this is the mean. Let's print something. Let's make it something bigger. I'll make it big there, but I'm not going to print it. Okay. Because if it's big, then it's too much to see. So I'm going to make it 100 or 200 by 200. Okay, they are powerful machines, so it does that. And I can take the mean. Okay. As you expect, the mean is going to 0. The standard deviation should be going to 1. This is a lot of large numbers. If you have large things, then the standard deviation goes to 1. Okay, so you can take the maximum, you can find the minimum, and different things like that you can do. Okay, you can sum along one column or sum along one row, so you can do that. You can take the transpose of the matrix. So if I do so M1, let's call it transpose. Just M1 dot T. If you do this, you're going to take the transpose. So since it took the transpose, if you find the mean and all these things, they'll be the same because it's just the transpose of the other one. Okay. We'll find NumPy useful as we go along. And then the next one we should do now is pandas. So it's pandas. Okay, data manipulation. Okay, so pandas helps you to do a lot of things. Okay. Most of the time, what we do is we use a data frame, and we use pandas to data frame to do what we want. Okay. So for instance, you can open a CSV file. A CSV file is a file that's comma separated. Okay. So I'm going to try to do that immediately because this is, so I'm going to skip some of this thing and I'll go to section 3.4. Let me show you that. So I go to this section 3.4. So there's this part on how to create series and data frames, but let's focus on what we use most of the time. Okay. So typically you want to load or save a CSV file, or you want to load or save a JSON file. So yeah, so you can do the JSON file. Even Excel, you can write out an Excel file. You can write a CSV file. So I'm going to load this CSV file, and I'm going to share the CSV file with you, so you can load it also. So there's a book by somebody called Jamie Chan. So he has many books on programming. One of the ones he has written is about machine learning in Python for beginners. So I have a Kindle version of it. So, but he has the resources online. So this is where I took this data set. And the one I'm going to use now is this pandas demo. Okay. So I will take the pandas demo and I'm going to send it to you. It's a small file, so it's not big, and I don't feel bad about sending it to you. Okay. It's a CSV file, so if you look at it, so you can download it. It's just 281 bytes, so it's a small file, but it illustrates many of the things we want to do. I can open the file and let you see what's in it. Okay. So it's a comma separated file. I don't know how to make this bigger. Edit view. Maybe there's something like preferences. I want to make this thing bigger so that you can see what I'm doing. Global setting, file setting, setting. Sorry, I've actually not used. Okay, let's do this. Let me also try to open it with Notepad. Because Notepad, at least I think I should be able to make it bigger. Can I? View. Okay, zoom. Okay, zoom in, Control plus. Okay. Okay, this works. Okay. So what's in the file? The top has the label for the column. So it has the module ID, okay? And then there's instructor, then there's TA, which is teaching assistant, and then there's enrollment, how many people are in that particular course, and then there's the rating either for the teacher or for the course, okay? So the first course is CSC 101, the instructor is Aaron, the teaching assistant, TA, is Vera, a 38 students in the course, and rating is 9, okay? If you look at this one, CS 102, okay? Or let's look at CS 101, the next one. Okay, the course ID is CS 101, the instructor is Beth, the TA is Carol, but the information about the enrollment is not there. How many students are enrolled in the class is not there. The rating is there. Or if you look at this one, CS 103, everything is there except the rating. The rating is not there. So this data is not clean, and it will be our job to clean it as part of the things that we are doing to learn about this thing. Okay. So I sent you the file. You can copy the file and put it in the same directory in which you are working. So this is the thing with this one. If I do pandas demo, I'm trying to figure out how do I put it in the same file in which I'm working. Yeah, so file. I want to be able to. There's a way to put a new code in your drive. I'm not okay for this one. I'm not an expert to know exactly how to put the code. I think somebody. Okay, let me upload to session storage. So I clicked on this folder, and it said I can upload to session storage. So what I want to upload, I have this now. Machine learning resources, and data sets, and that's demo. So I'm uploading it. Yeah. So it says ensure that your files are saved elsewhere. This runtime files will be deleted when this runtime is terminated. Okay. So for Colab, I just went to this folder and I could click this and I could upload my pandas demo.csv. Okay. Let's hope this is all I need to do. So so I'm going to write df equals DF is typical for data frame. And what to say is, you see, I already imported pandas as PD. I think I did it. Did I? Oh, no, I didn't. Okay, so that's the first thing I need to do. I need to first import pandas as PD. You can just say import pandas, but many people will do import pandas as PD. So we don't have to type pandas every time. You can just type PD. So I say PD dot read underscore CSV. So it's reading a CSV file. And I put the name of the file. Okay, and I do shift return. Okay, so it has read the file. Okay. How do I know that it has read the file? You can do different things. You can tell it to print df.head. Okay, so it prints the first 5 lines of the file that you've imported. So this one, 0, 1, 2, 3, 4. The first 5 lines of the file that you've read. It has printed it. Okay. It has this NaN because this was missing. So if you remember, it was missing. This one was also missing. Okay. And so if you look at the file, the notepad, okay, you see after Carol, this was missing. You just comma, and then 9. So that missing thing is interpreted by pandas as NaN, not a number. Okay. Then the line that has CS102, Aaron, Andy, 32, CS102, Aaron, Andy, 32, something is missing here also. Okay. So that is missing also. So it has not a number there. Okay. So everything has been read. You can find out the length of DF. And there are 11. So you can check and you see that there are exactly 11 lines of data. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11 lines of data. The header is not counted as one of the lines of the data. Okay? And then you can get what the headers are by telling it to print not column. I think it's column. Let me see. Okay, so it printed module ID because that's one. The instructor is the next one. TA, enrollment rating, and this one. Okay, so it printed all of them. Okay. If I change, okay, you can change a column and the name. For instance, instead of TA, you may want something else. So it's possible to do that. Okay, you can also print the last 5 rows. So if you, sorry, the last 3 rows. If you do print df.tail, tail, it will print for you the last 5 rows. Okay. If you want to print the last 2 rows, you can put 2 there. Okay. And it's print the last 2 rows. Okay. By default, it prints the head will print the top 5 rows, tail will print the bottom 5 rows. Okay. And then columns prints the columns. Okay. If you wanted to just print the index 0, 1, 2, 3, 10, you can do that also. Okay, so sorry, it just tells you the range of the index. It starts at 0, it stops at 11, and the step is 1. Okay. Okay. One thing that is really very good is you can tell it to give you descriptive statistics of everything you have. Okay. So let's do print df.describe. Hit enter. Okay, it gives you descriptive statistics only for the numerical part. Okay, so in this case, our data module ID is not numerical, instructor is not numerical, TA is not numerical, but the enrollment is numerical, is 38, 28 is numbers. The rating also is numerical, 997. Okay, so it can give you the average for the enrollment, the average for the rating, the I don't know if it gives you the standard deviation. Okay. Yeah, so it gives you how many things are in the enrollment, how many are in the rating. Okay. It gives you the mean for the enrollment, the mean for the rating, the standard deviation, the minimum, maximum, 25% percentile, 50%, 75%. Okay. This is one of the places where you know that your data is not clean. Okay. So I already know that I have the length of my data. Okay. So I think I printed it before. Yeah. The length of DF is 11. Okay. But when it wrote the number of enrollment, the count is 9. Okay. Then I know that there are two spaces in the enrollment. There are two places where there are two lines, there's no enrollment information given there. Okay. The rating is 8. So I know that there are 3 lines where the rating is not there. Okay. Otherwise, the rating should be 11, the enrollment should be 11. Okay. If you look at the data, you see that there are 2 places where there's no enrollment. So CS101 here, after Carol, there's no enrollment. And CS102, Beth Vera, after that, there's no enrollment. Okay, so those 2. And then there are 3 places where there's no rating. The first one is this CS102, Andy, because 32, and then there's a comma. The next one is this CS103, Gail Wesley, there's a comma. The last one is this CS104, Dan, there's a comma. So this is how you know already that, okay, my data needs to be cleaned because some things don't match up. Okay. We'll see how to clean the data later on. Okay. Then sometimes when you have the data, you may want to print some particular information. So you may want to print some particular information, and there are 2 things, or you may want to access some particular information. So there are 2 things you can use. One is lock, the other is iLock. Okay. Lock locates it using the label index or column names. Okay. And then iLock uses the integer index, the position. Okay. So we can take a look at a few examples to be able to do this. So if in this case now, I can do iLock 1 if I want to print anything from this. So I can use iLock, and then that will help me to print from this. So for instance, this is 0. So okay, so this is row 1, this is row 2, this is row 3. So if I want to print Beth, then is row 1, and then is column 2. So that will print Beth for me. So let's try to do it. But in this case, I'll do print df.iLock. Usually I miss it the first time. I1, 2. So this is Carol. So why is it Carol? So apparently this is, sorry, so this numbering here, 0, 1, 2, is not part of the data. So if you look in the data, there's no 0, 1, 2 on this case, in this place. It's just the Jupyter notebook that's helping us with visualizing it. So it's not there. So this is row 0. Okay. This is row 1. And in row 1, CS101 is in the 0th place. Beth is in the 1st place. Carol is in the 2nd place. Not a number is in the 3rd place. And 9 is in the 4th place. So if I do 1, then I'm getting this row. And then 2 will be Carol. So this is why it gives you Carol. What if you just want to get all the row 2? So I think I can do 1. Let me see. Sorry, iLock. Okay, so it prints for me. That's row one, the first thing, the second thing, the third thing, the fourth thing, and everything in row one. So it printed that for me. What if I want to print all of them? I don't know. So let's do one colon and see what's going to print for you. Yeah. So it prints from one all the way to the last one. So it omitted row zero. So if I do this, if we do 4 to 6, okay. So it just printed row 4 and row 5, up to but not including the last one. I think you so the iLock helps you to do it just like you would do NumPy array. But I think there's some other things with it. So let's say I do 4, comma, I do row 4 and I do 1, 2, 3. Okay. So it printed this one. Well, let's say I do 4 to 6 and 1, 2, 3. Okay. So you do 4 to 6 the row, and then 1, 2, 3 the column. Okay. So iLock helps you to do it just like you do with NumPy. Okay. There's another one which is lock. Okay. With lock, you can use the name. So you can use exactly the name that you want. Okay. So if you know the columns, so for instance, there's a column and the column is enrollment. So I think if I do this, you have to get the name correctly. So I think I'm doing an indexing wrong. So let me see if it's enrollment. Sorry, there's no enrollment double L. It's enrollment single L. Okay, but it still gives me an error because okay. First, let me get the header. Yeah, so exactly this. But I think I'm not. So if I put this there exactly, I have to tell it what I think I have to tell it something so that then it prints for me. I usually miss it unless I look at something. So it's df.log enrollment. Let me do this. Sorry. So I want to print the enrollment for everybody. Does this work? No, it doesn't work. Sorry, give me a minute. It's happened like this that the lock, I'm not. It takes me a few times to get it, and then I get what I'm doing. I think I need to do something like this. Sorry, let me see. Oh. I'm sorry, I have to think deeper to know how to get this lock. So the lock indexes it by anything, by label, index, or column names. So I want to index it by So I want to index it by I think this is what I'm supposed to do. I don't think I'm just supposed to, no, I don't think I'm just supposed to put on this one on. I need to put this in the middle. And it still does not. So key error is enrollment and the enrollment is wrong. Okay, I'll take a look at it and then the next time we meet, I'll be able to tell you how to use the enrollment, how to use the lock. Okay. For now, okay, we just think about df.lock. It works just like you would for numpy array. And this one should also, sorry. Sorry. I totally expected this to work. So let me try it again. So let me use this one. It should not work. For this quote, this expected that. Um, okay, I'll take a look at it and then I'll be able to get back to you to tell you exactly what you should do. Okay. I think what I want us to do now is I will show you how to deal with missing data. So one way to deal with missing data is you can just drop the rows that is missing. So yeah, so you can just drop the rows that are missing, and this is one thing you can do. Um, sorry. Okay, so actually, if I wanted to, I could. Okay, yeah, I will do that later. So I could. So I thought I did this. Sorry. Okay. Um, okay. So I'll look at how to use lock and be able to tell you the next time when we meet. So I think for now, um, the next thing I want us to do is how to um, drop different things. Okay. So one of the things you can do is you can try to find where there's missing data. Okay. Okay. So when there's missing data, it prints it as true, that this thing is null. So if you look at the original data, then for line 1, enrollment, the information was not there. So it prints it as true. Okay. Is it null or not? Yes, it's null. So it prints true here. And it prints true here. And you can count how many truths that you have. And that helps you to know how many missing data that you have. So if I do this, df dot is null, I can count how many truths that I have. So basically all I have to do is I have to sum everything and it will give me the number of truths that I have. So if I do this, okay, it gives me, it's null will give me this array and I can sum all of them. Okay. False is 0, true is 1. And I do this. And it tells me that enrollment has 2 gaps, rating has 3 gaps. Has 3 things that are missing. And then you can drop the row that is missing. Okay. So yeah, so you can drop the row that is missing. So let's try to do that now. If you just do df dot drop na, okay, it drops the row that is missing. Okay. So the row so you see now everything is as if nothing is missing. But row 1 is missing because it has been dropped. Row 4 and 5 are missing because they've been dropped. Row 8 is missing because it has been dropped. Row 10 is missing because it has been dropped. Okay. So it drops the rows that have something missing in it. Okay. Okay. You can also drop the columns that have something missing in it. Okay. Actually, when you do this df.drop_na, it returns another data frame. Okay. But the data frame it returns is this one that we are looking at. Okay. But the original data frame is still there. So this df is still there. So if I do df, if I print df, you see it will be exactly the same that I had before. Nothing is missing. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So nothing is missing. Okay. Because when you do df.drop_na, it returns a new data frame that has those things missing, those lines missing. So if I want to store it, I should put it in another data frame. So I do df2 is df.drop_na. So I do this. Okay. And then if I want to print df2, okay, df2 is the one that will have the ones that are missing, which is what I've just done now. Okay. So df2 has the missing lines. Okay. And then what about df? Df still has those lines that we had before. Okay. Df still has the same lines like we had before. And you have the naughty number and everything that's there. Okay. What if I want to drop columns that have something missing? You don't do that often, okay, to drop a column that has something missing. Usually we drop a row that has something missing. So in that case, I can create a df3 and I will tell it that I will put axis equals 1, and then it should drop the columns that have something missing. Okay, so if I do this, df3, because df.drop_na, and I do axis equals 1, okay. And I can check df3. Okay. Okay, so you see the enrollment column has disappeared. The rating column has disappeared, okay, because they have something missed, okay. But the module ID, instructor, and TI are still there. This one often you don't have to use it often. The one you use often is just drop NA. If you just do df.drop_na, it assumes axis is 0, and that means it should drop the rows that have something that is missing. You can convert this back to NumPy array, and you can find the correlation. You can use pandas also to find the correlation between the rows. So you can do different things like that. Okay, so drop n is an easy way to just drop the missing rows. And now the data that you have is clean. So this df2 is clean. And then I can use it for the machine learning fitting and everything that I want to do, because it doesn't have any row missing and it doesn't have any column missing. Later on, we will see how if something is missing, like from the original df, let's go there, like this one, I can replace this number with the average of everybody. This number also, I can replace it with the average of the column. Okay, so this is possible to do. Yeah. Okay. So I said the next time I'll look at how to select using lock, and then also I'll look at how to select using um, some kind of masking. There's a way you can do masking and select using masking. I think I'll do that the next time we meet, and we'll start with that. Yeah. So if you have questions, you can ask questions. Otherwise, then we'll meet again on Wednesday. Okay. Does anybody have questions?
Well, hello, Prof.
Yes.
Oh, okay. I tried to download because I was using my phone for this meeting
Sorry, please hold on.
and I couldn't access the CSV file.
Damilare, please hold on.
All right.
Okay, go ahead. Bluetooth mode. Go ahead, Damilare.
All right. I said I accessed this meeting with my phone and I couldn't access the CSV file that you sent to us. So
Okay.
I don't know if you can help us send it via email, maybe next email.
So I'll send it email the CSV file. Yeah. Okay. Okay. So thank you very much. So the next time we meet, we start with using lock and also how to select things in the pandas data frame. And then after the pandas data frame, I think we'll go on to matplotlib, which is short. And then scikit-learn. Yeah. So by then also I'll have a few projects, simple projects, one to learn and another one to do a little bit of research, which I'll give to all of us. Yeah. Okay. Thank you very much, everybody. I'll
Thank
send
you,
you
Prof.
Thank you,
I'll
sir.
send you the recording and any updates that I have. Yeah. This CSV file also I'll share with you. Yeah.
All right.
Thank
Thank you, sir.